Welcome back to AI Research Weekly, the show that dives deep into the papers shaping our field. I'm Nova, here to probe the cutting edge.
And I'm Onyx, ready to contextualize those findings and connect them to the broader currents of AI. This week, we're seeing a significant push in agentic AI, particularly around omnimodal capabilities, and some fascinating methodological innovations in training and evaluation.
Absolutely. It feels like the agent paradigm is finally moving beyond theoretical constructs to something genuinely robust and capable. The sheer volume of work on autonomous agents, especially those leveraging multiple modalities and advanced tool use, is striking. We saw over 570 papers ingested just for this week's digest.
Indeed, and a lot of that momentum is driven by the need for more systematic evaluation, which brings us to our first deep dive, MobilityBench. It's a new benchmark coming out of a map designed to evaluate LLM-based route planning agents in real-world scenarios.
MobilityBench. So, what's the core contribution here? We've had benchmarks for navigation before, but route planning agents are a different beast, right?
Exactly. The key here is its focus on real user queries and a scalable, deterministic evaluation environment. They've used large-scale anonymized real user queries from AMAP, spanning multiple cities worldwide, covering everything from simple point-to-point to complex multi-waypoint, multimodal planning, and even preference-aware navigation. The truly novel part, in my view, is the deterministic API replay sandbox. This is critical for reproducibility. It caches responses from routing and points of interest APIs, eliminating the non-determinism that usually plagues evaluation with live services.
That API replay sandbox is a huge deal. One of the biggest headaches in agentic research is inconsistent environments. But what did they actually find when they ran agents through it? What are the current LLMs good at, and where do they fall short?
The results are pretty illuminating. Current LLM-based route planning agents perform competently on basic information retrieval and direct route planning tasks. They can get from A to B. But where they really struggle, and this is a significant finding, is with preference-constrained route planning. Think about personalized mobility applications like find me a route that avoids highways and has a good coffee shop stop halfway. That's where they show substantial room for improvement.
Right. So the so what here is that while LLMs can act as competent rule followers for simple routing, integrating nuanced, dynamic user preferences into a planning horizon still presents a critical challenge. It's not just about tool use, but about understanding and integrating complex constraints into a multi-step planning process. How comprehensive is this dataset?
It's impressive in scope. It covers queries from over 350 cities worldwide, demonstrating broad geographic coverage and extensibility. The multidimensional evaluation protocol is also notable, focusing on outcome validity, instruction understanding, planning, tool use, and efficiency, integrating objective criteria beyond just subjective LLM-based judging. They're really trying to make this an end-to-end reproducible evaluation.
And that links nicely to the broader problems we're seeing, like multi-agent LLM systems suffering from false positives, reporting success on tasks that fail strict validation. MobilityBench provides a solid framework to mitigate that in a specific domain. So, from planning agents to omnimodal agents, let's talk about OmniGaia.
Yes, OmniGaia towards native omnimodal AI agents. This paper really pushes the envelope on what we mean by multimodal. Most multimodal LLMs today are primarily bimodal, vision language, perhaps text audio. OmniGaia steps into the realm of omnimodal, meaning it demands deep reasoning and multi-turn tool execution across video, audio, and image modalities simultaneously.
Okay, OmniGaia, that's a big claim. What makes it omnimodal beyond just tacking on more input types? Is it genuinely integrating information across these streams for complex reasoning?
That's precisely it. The benchmark features 360 tasks across 9 real-world domains. Crucially, these aren't just simple classification tasks. They incorporate both video with audio and image plus audio settings and demand multi-turn tool use, like web search, browsing, code execution, for verifiable, open-form answers. The authors used a novel omnimodal event graph approach to construct OmniGaia, synthesizing complex, multi-hop queries that necessitate cross-modal reasoning and external tool integration. So it's about the interaction and integration of modalities.
An event graph for query synthesis sounds powerful for creating those complex multi-hop scenarios. What about the agents themselves? Did they propose a new architecture or training paradigm to tackle this?
They did. Alongside the benchmark, they propose OmniAtlas, a native omnimodal foundation agent. OmniAtlas operates under a tool-integrated reasoning paradigm with active omnimodal perception to selectively process long media segments. Its training recipe is also quite innovative. High-quality tool-integrated trajectories, synthesized via hindsight-guided tree exploration, supervised learning, and Omni-DPO for fine-grained error correction. This is aimed at enhancing tool use capabilities of open-source models.
Hindsight-guided tree exploration and Omni-DPO for error correction? That's a sophisticated RLHF approach for tool use. But what do the actual results look like on this challenging benchmark? How far are we from truly competent omnimodal agents?
The benchmark really highlights the current gap. The strongest proprietary model they tested, Gemini 3 Pro, achieved 62.5 pass at 1. An open-source baseline, Qwen 3 Omni, scored significantly lower at 13.3. However, with the OmniAtlas training recipe, Qwen 3 Omni's performance improved to 20.8. So, while proprietary models have a lead, the training methodology does yield substantial gains for open models. It highlights the immense difficulty of truly general omnimodal intelligence and the need for more specialized training techniques for these agentic systems. It effectively maps out the current frontier and shows how much further we have to go.
Okay, so OmniGaia sets a high bar and provides a roadmap for what's needed in truly generalist agents. Sticking with multimodal capabilities, but shifting gears slightly to generation, DreamID Omni caught my eye. This promises a unified framework for controllable human-centric audio-video generation. This sounds like it addresses a lot of the fragmented efforts we've seen in deepfakes and personalized media.
It really does. DreamID Omni unifies 3 distinct human-centric audio-video generation tasks that were previously tackled by separate models: reference-based audio-video generation, video editing based on reference, and audio-driven video animation. The core contribution is bringing these disparate tasks into a single cohesive framework while achieving state-of-the-art performance across all of them.
Unifying 3 complex generation tasks is no small feat. What's the secret sauce in their architecture or training that allows for this generalization?
There are a couple of key innovations. First, the Symmetric Conditional Diffusion Transformer, or SCDIT, effectively integrates heterogeneous conditioning signals, things like reference images, voice timbres, source videos, driving audio, into a shared latent space. This design is what allows for seamless task switching without needing architectural changes. Second, they introduce a dual-level disentanglement strategy. This involves synchronized rope at the signal level and structured captions at the semantic level. This specifically resolves identity timbre binding failures and speaker confusion, which are notorious problems in multi-person audio-video generation.
That dual-level disentanglement sounds crucial for maintaining consistency and avoiding artifacts, especially with multiple subjects. We've all seen generated content where identity or voice drifts. And the training, how do they manage to train one model to excel at these different, albeit related, tasks?
They employ a multitask progressive training scheme. It starts by prioritizing weakly constrained tasks like reference-based audio-video generation, and then progressively introduces more strongly constrained tasks like video editing or audio-driven animation. This prevents overfitting and ensures superior performance across the diverse objectives. The results are quite impressive. The framework demonstrates comprehensive state-of-the-art performance across video fidelity, audio quality, and audio-visual consistency, even surpassing leading proprietary commercial models.
Surpassing commercial models is a big claim. The release of their code will be interesting to see how it holds up in the wild. This really points to a future where highly controllable, personalized media generation from a single model is becoming practical. But speaking of how models reason about visual information, I found the paper Imagination Helps Visual Reasoning, but Not Yet in Latent Space, to be a fascinating counter-narrative. It challenges assumptions about how MLLMs process visual data. Ah, yes, this one was a great reality check. We often assume that stronger visual encoders lead to richer latent representations that directly support reasoning. This paper reveals that's not necessarily the case, at least not yet. Their core contribution is identifying two critical disconnections in latent visual reasoning via causal mediation analysis. Tell me about these disconnections. What are they and what do they imply about how MLMs actually reason about images?
The first is the input latent disconnect. They found that even significant perturbations to input images lead to negligibly small changes in the latent tokens. The latent space seems surprisingly insensitive to input variations. The second is the latent answer disconnect, where perturbing the latent tokens themselves minimally impacts the final answer produced by the MLLM. This suggests that the latent tokens, despite being the visual representation, exhibit high homogeneity and encode limited discriminative visual information sufficient for downstream reasoning on their own.
That's quite counterintuitive. It almost implies the visual latent space is a bit of a bottleneck, or perhaps the models are extracting just enough for basic recognition, but not for deep compositional reasoning in that latent vector space. So if latent space isn't cutting it, what's their alternative?
Their proposed solution, Cap-Imagine, bypasses latent space visual reasoning entirely and instead leverages text space imagination. Essentially, it uses the MLLM to generate detailed textual descriptions and inferred properties from the image, and then uses that text for reasoning. They show this text space imagination method significantly outperforms complex latent space baselines, achieving 4.0% higher accuracy on HRBench 8K and 4.9% higher on MME Real-World Light.
Wow, that's a pretty compelling argument for explicit textual intermediate steps. It resonates with chain of thought reasoning, where articulating steps in natural language often improves performance. It suggests that for complex visual reasoning, our models might be better off thinking in language about what they see, rather than directly manipulating abstract, latent features. It's more interpretable, too.
Absolutely. It's a clear methodological innovation and a strong signal. The why behind it is crucial. Previous latent space methods often suffer from dilution of discriminative semantics due to compression or latent mode collapse. Cap-Imagine avoids this by operating in a space where models are already highly proficient at reasoning, text. It implies that true visual reasoning might emerge not from a perfect latent space, but from a robust interface between perception and linguistic reasoning. This is a crucial insight for how we design future multimodal models and perhaps for understanding the nature of reasoning itself.
That's a big takeaway for researchers working on multimodal architectures. Moving from reasoning to generation, the proliferation of diffusion models has been huge. We're seeing DLLM, simple diffusion language modeling, which is trying to unify that space.
Right, DLLM, or diffusion language modeling. This paper acknowledges a practical problem in the diffusion language modeling space: fragmentation. There are various ad hoc research codebases, making reproduction and extension difficult. DLLM is introduced as an open-source framework that unifies the core components, training, inference, and evaluation, for diffusion language models.
So it's less about a novel architectural breakthrough and more about bringing order to a chaotic subfield. A much-needed infrastructure play, then?
Precisely. It provides reproducible recipes for building small DLMs from scratch, allowing the conversion of any BERT-style encoder or autoregressive LM into a DLM with accessible compute. They're releasing checkpoints for these smaller DLMs, which should lower the barrier to entry significantly. The key contribution isn't a new model that achieves SOTA, but a framework that makes it easier for the community to build and evaluate SOTA diffusion language models transparently. This is vital for accelerating research in the long run.
That's huge for democratizing access and making research reproducible. Diffusion models are powerful, but complexity can be a major hurdle. Speaking of accelerating research and bringing us back to agents, one last paper that ties a lot of this together is Search More, Think Less: Rethinking Long-Horizon Agentic Search for Efficiency and Generalization. This seems to tackle a core issue with how agents explore and synthesize information.
It really does, Nova. This paper, introducing the SMTL framework, addresses the scalability bottleneck in long-horizon agentic search. Existing deep research agents often rely on sequential reasoning, which can become incredibly inefficient. SMTL proposes a fundamental shift, replacing that sequential reasoning with a parallel agentic workflow for evidence acquisition and structured context management.
Parallel evidence acquisition. That makes intuitive sense for efficiency. We don't just read one paper at a time and then move to the next sequentially. We often have multiple tabs open, running parallel searches. How significant are the efficiency gains they report?
The gains are substantial. SMTL reduces the average number of reasoning steps on the BrowseComp benchmark by 70.7% compared to previous methods like MiroThinker, while actually improving accuracy. For inference latency, they report reductions of up to 2.6x. That's a game changer for deploying these agents in real-time scenarios.
And the think less part, is it implying a simpler reasoning process or just offloading some cognitive load to parallel search?
It's more about smarter orchestration of the search rather than reducing cognitive load in the conventional sense. The think less refers to minimizing redundant internal reasoning steps by having a more efficient and generalized way of acquiring external evidence. They also introduce a unified data synthesis pipeline to construct search tasks spanning both deterministic question answering and open-ended research scenarios, which improves generalization across task types. This pipeline helps create representative multi-type search tasks, reducing redundant samples for training.
So it's about making the search process itself more intelligent and less wasteful, leading to better generalization and faster results. Given the recurring problem of multi-agent LLM systems suffering from false positives, a more efficient and validated evidence acquisition strategy like this seems critical.
Exactly. And the framework is trained end-to-end using a combination of supervised fine-tuning and reinforcement learning, showcasing the efficacy of combining these paradigms for complex, long-horizon tasks. SMTL achieves strong, often state-of-the-art performance across multiple benchmarks: 48.6% on BrowseComp, 75.7% on Gaia, 82.0% on Xbench, and 45.9% on Deep Research Bench. This truly moves us towards more practical and deployable agentic systems.
This week really underscores the increasing maturity of agentic AI. From specific benchmarks like MobilityBench to omnimodal challenges in OmniGaia to architectural unification in DreamID Omni, and even rethinking the reasoning process itself in Imagination Helps Visual Reasoning and the efficiency of search in SMTL. It feels like the field is solidifying the foundations for truly autonomous, capable systems.
I agree, Nova. We're moving beyond isolated capabilities towards integrated, robust, and efficient agents. The focus on methodological innovations, diagnostic-driven training, multitask progressive schemes, parallel search is critical. Next week, I expect we'll see further developments in addressing the reliability and structural integrity of multi-agent systems, especially as the volume of AI-generated content continues to swell. The theoretical concepts of Grandich causal chain enforcement and resonant meaning fields also hint at deeper thinking around knowledge representation and causal integrity that these emerging agentic systems will ultimately need to grapple with.
Fascinating insights, as always, Onyx. That's all the time we have for this week's AI Research Weekly. Join us next time for more deep dives into the bleeding edge of artificial intelligence.
Until then, keep pushing the boundaries.